Guys, sorry about the interruption there. So I'm going to pick up on this problem that cos theta was negative root 3 over 2. I just figured out that the reference angle was 30 degrees. And so in quadrant 2 and quadrant 3, I'm going to have 180 minus 30 degrees, or 150 degrees for theta, and 180 plus 30 degrees, or 210 degrees for theta. Okay. In question 2, where is tan theta equal to 0? And so I might want to check that first in solving for theta. So I'll do second function tan. Before that, actually check your mode. Make sure you're in degree. We're good here. So second tan inverse 0 degrees, or 0, gives us 0 degrees. So that's actually your reference angle, right? Which means that basically we want to figure out what a reference, or where a reference angle of 0 degrees would be. And so that would be actually right here along the x-axis and right here. So theta will actually be 0 degrees, 180 degrees, and because they've included up to 360, I'm going to include 360 in here as well. Okay, so by the time I get back to 0, I'll be at 360 again. Where does sine inverse equal 1/2? That's asking where is sine inverse a positive 1/2? According to CAST, sine would be positive in quadrant 1 and quadrant 2. And then when I want to find the reference angle, second sine, 1/2 or 0.5. Reference angle is 30 degrees. If you're curious how to do that with your hand rule, you basically have your hand, you need one finger below, so that's sine, because sine is below your reference angle. And so to get that, we hold down our ring finger, and the reference angle is 30 degrees. Which means I have two solutions, one in quadrant 1, which is 30 degrees, and one in quadrant 2 at 150 degrees, or 180 minus 30. Okay, the last part of trig is the problem solving with sine and cosine law. So no more x, y, and r or anything like that. We're into our sine law, which is stated here as a formula. We would use that when basically we have a pair, an angle, and its opposite side. And then we fall into the ambiguous case when whatever reference angle we solve for is greater than the given angle, and that might imply that there's two solutions. The cosine law, there's two versions. This is what I call the side version. This is the angle version. We fall into the cosine law under the condition side angle side, so two sides in the contained angle, or having all three sides. So let's look at example G here for a second. Solve for the side length B and angle A in a triangle ABC, where AB is 4.5 centimeters, BC is 7.8 centimeters, and angle B is 79 degrees. So I'm going to draw just a standard triangle, not to scale at all, and I'm going to label it A, B, C. So there's my triangle, ABC, and AB is 4.5 centimeters, BC is 7.8 centimeters, and angle B is 79 degrees. Okay. When I look at this triangle, I see side, angle, side. So I'm in the cosine law. If I wanted to use the sine law, I need a pair, which I'm missing either an angle or a side in each of my three pairs. So I'm going to go use the cosine law because I need to solve for a side length, little b. I'm going to rearrange that formula a little bit. So instead of b squared plus c squared, I'm going to go a squared plus c squared minus 2ac cos capital B. I've got side little a, I've got side little c, and I've got capital B, so I have everything I need to use this formula. So b squared is 7.8 squared plus 4.5 squared minus 2 times a, 7.8 times c, 4.5 cosine of 79 degrees. I'm going to go ahead and type all of that in. So 7.8 squared plus 4.5 squared minus 2 times 7.8 times 4.5 times cosine 79. 67.695. And then I'm going to square root that. Answer to get little b as 8 point, we'll go to the nearest tenth, 2 centimeters. Okay, so little b, 8.2 centimeters. Seems reasonable in this triangle. I was also asked to solve for angle A. And so in solving for angle A, I could go to the second version of the cosine law, which I'm going to, the cos A version. And it's already solving for capital A, so I don't have to rearrange it or anything, or change out the letters. Okay, running out of room, so I'm just going to show you on my calculator what I would type in. So I would basically go b squared, b is 8.2 squared, plus c squared, plus c squared, c was 4.5, minus 7.8 squared. On my calculator, because I didn't use brackets, I'm going to hit enter. I'm going to divide that by 2 times 8.2 times 4.5. So divide by 2 times 8.2 times 4.5. And I get cos A as 0.36 and then 1 repeating. In order to find angle A, I need to second cosine or cos inverse that answer. And I get 69 degrees. Okay. So that question was all about the cosine law. We have one last question. Having a feeling it's probably going to be the sine law, since we haven't covered it yet. And there's a note at the top that bearings are measured from north and measured clockwise. So I'm assuming this question has bearings as well. Let's take a read through. A pilot leaves the base flying on a bearing of 340 degrees for 46 kilometers. After 30 minutes, he changes the course to 108 degrees until he is due north of the base. How far does he have to fly south to return to the base? Okay, so I'm just going to start with a kind of a point. And I'm going to say, okay, this is the pilot leaving the base. On a bearing of 340, just a quick arrow. I'm going to draw my north arrow. 340 degrees clockwise from north is just about one full rotation to 360. So 340 degrees, we're headed kind of in this northwest direction. After 30 minutes, he changes course. So to 108 degrees. So if I was here, and this is kind of the north arrow again, we would change on a course to 108, so assuming that's 90. Basically, we're changing back this way, 108. Go back to this way, and then it says, and he keeps going until he's directly north of the base, and then he's going to fly south to return to the base. And we were asked, how far does he have to fly south? So that would be this length right here. How far does he have to fly south? There's a couple angles I can fill in. basically, if this is 340, then this little angle right here is 20 degrees to make a full 360. I was told that in that first trip on 400 or 340 degrees, that was 46 kilometers. Okay, and then I basically, I'm going to look, I don't have this angle right here. I've only told this one is 108 and not told that third angle right there. So I'm starting to question if we even have enough information to answer this question. And I'm thinking not. Okay. Because if I'm going to look at this, I need basically either use cosine law or sine law. I need at least two sides, which I didn't provide you.